Okay, guys, in this segment, we're going to be talking about the bones of the skeletal system. So let's start by talking about the specific parts of the skeletal system. So when we say skeletal system, we're talking about the individual bones, so of your skeleton, your joints, so where the bones meet, or articulation, sometimes they're called, where it articulates with another one, the cartilage that's on the bones, and the ligaments that are going to hold bones together. So our skeletal system can be divided up into two different kind of skeletal systems. This you've already kind of seen because you've outlined these parts of the chapter, but the axial skeleton is going to be the main axis of your body. So that's going to be your head, your backbone, and your thorax, right? So remember thoracic cavity, which is going to be your ribs, your sternum. So your thorax, your bony thorax is kind of how the book says it now. That's going to be your ribs and your sternum. The second part is going to be the appendicular skeleton. This is going to be your limbs or your appendages. That's why it's called appendicular skeleton. And then what holds them onto your body. So your pectoral girdle, which is your shoulders, and your pelvic girdle, which is your hips. First, start with the skull. The skull has two sets of bones. It has the bones of your head, so like the top part of your head or your cranium, and there's 8 of those that come together to keep your brain safe. And then it has the 14 facial bones, and these are going to hold your eyeballs and have all of your muscles connected to them. The bones of your skull are fused together by sutures, which kind of look like seams, or it makes kind of look like the bone has been stitched together. The only bone in your skull that is movable is going to be your mandible, which is the lower jawbone, and it's movable so that you can talk and eat. Next is the hyoid bone. This is the only bone in your body that doesn't articulate or connect with another bone. This is actually the bone that your tongue muscle is connected to, and it's going to be in your throat. So next we're going to look at the fetal skeleton. So that'd be a baby skeleton. And when you look at the fetal skeleton, it's very large compared to an infant's body length. So it's a lot, like they look almost like they're top heavy. And it's different from an adult skeleton because it has fontanelles. And fontanelles are what we commonly call soft spots. You know how they say, like, don't touch a baby's head on the soft spot? That's because there's actually this fibrous membrane that connects the plates of the skull together, because we want to be able to let the skull plates shift. This allows birthing to be an easier process because you have to get the baby's head through the hip bones. So like when a baby's too big to fit out, like too big to come out, what that means is that their head is actually bigger than the circle in their hip bones, and it can't fit through the hip bones. So fontanelles actually are what kind of crush and let like the head get that cone shape, right, so that the baby can fit through the hip bones. In addition, the fontanelles are going to let babies continue to, the brains continue to grow after they're born, and the fontanelles will actually close up, and the bones will kind of joint together, and that's where our sutures get formed. They kind of like stitch together, and that will happen within the first 2 years after a baby's born. The next part of the axial skeleton is the vertebral column. This is commonly known as your backbone. So there are going to be 26 individual vertebrae that are separated by our intervertebral discs. And let's remember, our intervertebral discs are made of fibrocartilage, right? Because it can withstand great pressure and it supports things. So what you have is you have 7 cervical vertebrae, you have 12 thoracic vertebrae, and 5 lumbar. The easiest way to remember that is think of breakfast, lunch, and dinner. So breakfast at 7, so those are the top 7. And then you go to lunch. Lunch is at noontime or at 12, so you have 12 thoracic. Then you have dinner at 5, so there are 5 lumbar. So 7, 12, and 5 for your cervical, thoracic, and lumbar. And the vertebrae are going to get bigger as you go down the spinal column. Once you get down to the bottom, you have 9 vertebrae that fuse together to form 2 individual bones. So first you have your sacrum, and that's why you have those holes in your sacrum, because those were actually holes between the individual vertebrae, but then they fused together. So 5 of them fused to make the sacrum, then 3 of them fused to make the coccyx down the bottom. The last part of the axial skeleton is going to be the thorax. So this includes the, how many? 1, 2, I guess two major areas. First, we have our sternum. Oh, I guess three they're gonna say because they're including your thoracic vertebrae, but whatever. So first we'll have our sternum. So your sternum is gonna have three different parts. We already know the jugular notch, which you can feel at your throat where like the Adam's apple is. Right there is your jugular notch. You have the manubrium, the body. Underneath you have the xiphoid process. Then you have all of your ribs. Right, we have 7 true ribs. So true ribs actually connect directly to the sternum with cartilage. So right, I'm going to write on it in a second. Right here, this, right, that makes these ones true ribs. These are the first 7. And then you have the next pairs 8 through 12. The next ones are going to connect to, these are your false ribs, and they connect to the cartilage of the last true rib. So see how these ones, this one, this one, this one, this one, they all connect by cartilage up to that other rib, right? So they're not actually connected directly to the sternum like these ones are. They're connected by cartilage up to the sternum. And then you have your last 2 down here. These ones are floating ribs, and they don't connect to the sternum by any cartilage or anything. They just kind of hang out, right? So our ribs and our sternum are going to make up our thoracic cavity. Plus, add in your thoracic vertebrae. That's fine. We now move into our appendicular skeleton. We're going to talk about the pectoral girdle or the shoulder girdle. This is what actually connects your arms to your axial skeleton. So we have 2 bones that make up this pectoral girdle or shoulder girdle. It's your clavicle or your collarbone, which is that top thin one, and your scapula, which is your shoulder bone. All right. They make the joint for your arm to connect to. Right here, that glenoid cavity and the head of the humerus. Right, that joint right there, which is actually a very, very weak joint, right? That's why people can dislocate their shoulders so easily, because there's not a lot of bone support around that joint, and a lot of that joint is reliant upon tendons and ligaments to actually keep your scapula and your arm connected to each other. But it does allow a lot more freedom than the other joints in your body. So here we have our scapula and our clavicle. Next, we go to the bones of our upper limbs. So the bones of our upper limbs, we have the humerus, which is your first one, which is your upper arm bone. And then you have your radius and ulnar, which make up your forearm. So the forearm is the lower arm, and the upper arm is the top part of your arm, okay? The humerus is going to form the main part of the arm. The proximal, which is closest area to your body, right here, is going to articulate with the glenoid cavity of the scapula, so that hooks up to your scapula. The distal end, or the bottom down here, is what's going to hook up to your forearm. So that hooks up to the radius and the ulnar. And then we get to our forearm. You have the radius and the ulnar. And let's remember that your ulnar has that U shape in it right here, right? That reminds you of ulnar. And the radius has the round head, right? And that's how you remember radius, because a circle can have a radius. So proximal side is going to hook up to the bottom of the humerus. The distal side of the radius and the ulnar are going to hook up to your hand, right? Then we have our pelvic girdle. So pelvic girdle, like our pectoral girdle, is where the limbs are going to connect to the axial skeleton. So pelvic girdle is part of the axial skeleton also. It's going to connect the limbs to the axial skeleton. It's going to be composed of your hip bones, and your hip bones are actually 3 bones together. You have your ilium, which is your wing. You have your ischium, which is your butt. That's what you sit on. So the bones that you feel on the floor when you sit, or you can feel digging into a chair, your butt bones are going to be your ischium. Then you have the pubis in the front. Those are the pubic bones. After that, we go into our lower limbs. So our legs are going to be formed by our femur, which is your thigh bone, and then your tibia and fibula, which are your lower leg. The femur is going to be the biggest bone in the body. It's going to articulate with the hips into the acetabulum. The distal end, or the furthest end from the body, is going to articulate with the tibia, right? The tibia over here, which is the bigger of the 2 bones. This is your tibia. Your tibia on the top articulates with the femur, and that helps form that knee joint. And on the bottom, it's going to articulate with your ankle, with the bones of your ankle. Then you have your hands and your feet. So for hands and feet, I put these together on one page because they are very similar. So for your hands, you have your carpals, and this guy's a hand on this side. So this, right, you have your carpals, which are your wrist bones. You have your metacarpals, which is your palm of your hand, and then you have phalanges, which are your thumbs and fingers. And then for your feet, you have your tarsals, which is your ankle bones. You have your metatarsals, which is going to be the arch of your foot, and then the phalanges, which are your toes. All right, so carpals, metacarpals, phalanges, tarsals, metatarsals, phalanges. Then we get into joints. Joints are going to be an articulation where two or more bones meet. So our joints allow our bones to bend, and they allow us to move. Without joints, we wouldn't actually be able to move as easily as we can move now. So they allow for mobility. Our joints are classified in two different ways. They're going to be classified functionally and structurally. So functionally is going to be how they work. Structurally is what they're made out of, right? And these classifications kind of run together. You'll see that on the next slide. All right, next we get to our functional and structural classification of joints. So how I did this is I put these all in one kind of graph together. So we're going to start looking at this top group, which I'm going to actually draw a line right here separating them. We're going to start looking at this top group. And when we look at this, this side is functional. This side is structural. Okay, for the different classifications. So for our functional classification, we go for synarthroses, which are immovable. Then if we go down, we have amphiarthroses, which are next, which are slightly movable. And at the bottom, we have diarthroses, which are freely movable. So we're talking about the different amount of mobility within a joint. If we look at those joints structurally, you have fibrous joints. So these are joints that are filled with some kind of fibrous tissue. Then we have cartilaginous joints. These are joints that are filled with cartilage. And then we have our synovial joints, which are joints that are filled with synovial fluid. All right, but both of these kind of classifications can run together. So your synarthroses, these up top, are also your fibrous joints. These are joints that don't move at all. This is things like the sutures in your skull. Those don't move. Those are knit together, right? Or you have the joint between like the radius, the tibia and the fibula, right? Between the tibia and fibula, there's a joint there because the bones are touching, so they're jointed. But there's not movement in that joint, and it's kind of connected together or knit together by some fibrous connective tissue. So those are going to be synarthroses. When you go down a level, you then get to your amphiarthroses. So we're now at this one. Amphiarthroses are going to be your slightly movable joints. These are joints that are cartilaginous joints in structure, right? So these ones are going to be things like the joints between your vertebrae that have fibrocartilage in there. And between your hip bones where the pubic symphysis is, right where the hip bones meet, that is also a cartilaginous joint or an amphiarthrosis. They don't have a lot of movement, but they do move a little bit. And then our last one are our diarthroses down the bottom here. So our diarthroses are going to be our freely movable joints, and our freely movable joints tend to be our synovial joints when we look at the structure of them. These are joints like your shoulder. These are the joints that when you think joint, you're talking about synovial joints. We have a little bit more about synovial on the next slide. But does this make sense? So we have functional classification, structural classification, and we go from no movement to slight movement to freely movable. And if you look at structure, it's going to be a fibrous joint, a cartilaginous joint, or a synovial joint. All right, so lastly is our synovial joints. So there are 6 different types. And these are the joints that you can move all on their own, or you can move freely, right? And they have different types of movement depending on what joint you're talking about. So if we go through these, my first one that I've written down is a plane joint, which would be this one down here. Okay, a plane joint is 2 flat surfaces that are going to, so here's a drawing of it, 2 flat surfaces up against each other. And they move in a little bit of direction. Think of your wrist, right? So it can go front and back and slightly side to side, but not really, right? So it's going to have a little bit, the front and back, and a little bit of side to side movement. If you hold your forearm and move your wrist around, you can see it. It moves almost in one direction more than the other, and front to back. That's going to be a plane joint. It's 2 flat surfaces on each other. Next one is a hinge joint. Hinge is going to open like a door. Okay, so your elbow, this one, your elbow is your hinge joint. Your elbow can shut and it can open up to straight. It doesn't go past straight. Another hinge joint would be your knee. That's going to be hinge joint, right? Your legs can bend can fold under you and then open up to straight, but they don't go past that motion. After that, you get your pivot joint. So the pivot joint is going to be radius and ulnar. If you look at your radius and ulnar, if you put your hand out flat, palm up, right, and then you turn it till your palm down, that actually causes your radius to roll around your ulna, which is a pivot joint. All right, it rolls around like that. Your neck and your head is also a pivot joint, right? Remember we talked about the dens? Your head rotates around the dens. Then you have a condylar joint, and that would be the joint of your fingers. That's up here. So if you look at where your fingers connect to your palm of your hand, those are condylar joints. All right. They open and shut. They have slight side to side motion, but not a ton. Then you have a saddle. Saddle joint is at your thumb. All right, your thumb moves different than your fingers. There's absolutely no twist in a saddle joint because it's like taking two saddles and putting them upside down on each other. And that's how it forms. If you want to ask me about that in class, I can show you in more detail what that means. And then the last one is ball and socket. Ball and socket is one we all know. It's your arms, that's your hips. It has the biggest range of motion in the most directions is your ball and socket joint. So write down any questions you might have. Ask me about them tomorrow or next time we have class. And thank you for listening to the lecture.